Having understood about CIDR for a network and what is the purpose of private CIDRs and public CIDRs, we will now look at when we have a network in place, and I will take this example as a network with a CIDR of 10.0.0.0/16 as its CIDR. We might need a means of dividing the network into smaller pieces to manage it with various purposes as to who can connect to what traffic is allowed, which is all done using route tables and firewall rules. What we do is we create what is called as subnets. So if I were to call this as subnet 1, subnet 2, and subnet 3, for example, I'm going to split my entire network, which is 10.0.0.0/16, into multiple sub networks, or it is a logical grouping of the network into smaller components. And when we do this, each subnet is given a CIDR which has to fall within the 10.0.0.0/16 CIDR. In this example, I might say the first network is going to be 10.0.1.0/24. The second subnet will be 10.0.2.0/24, and the third subnet will be 10.0.3.0/24. Now, it's not necessary you split them in this manner. This is only an example to tell. And when I give this as my IP CIDR for my subnets, I get 256 IP addresses for each subnet. By doing this, I have now logically grouped my network into 3 sub components, and I can give various options like DHCP options, security rules in the form of firewall rules, route tables for interconnectivity, and other options which come in handy. For example, I might group project-specific computers into a particular subnet, or depending on the environment in which they are running, whether they are dev, test, within my organization I might set up, or department-specific subnets, etc. Now, what we need to also keep in mind is when we create subnets inside a network, the CIDR range is already given when we create a subnet, and that subnet CIDR should fall within the CIDR of the network itself. That is the first thing. Number 2, for every subnet that is created, the first IP address and the last IP address is reserved for the network itself. For example, if I take the case of subnet 1, 10.0.1.0 and 10.0.1.255 cannot be assigned to any computer in that network. This is used by networking internally for various purposes. So you actually get only 254 IP addresses to work with for your computers in these subnets. By creating subnets, you get the ability to logically group computers based on your needs and manage other network rules and connectivity which can be applicable to each subnet as per your organizational or project specific requirements. When you create a computer in a network, you will place it in a specific subnet. So if I'm placing a computer, I would specifically put it in a network in a subnet, in a network in a subnet, in a network in a subnet. And actually, I don't place the computer itself in a subnet. I actually identify a network interface card of a computer to be in a subnet. So it is possible that one computer can have multiple network interface cards, and each network interface card is either in a different subnet, or for that matter, I might have the network interface card associated to an entirely different network itself. What is the reason for doing this? I have various networks in my organization. As a simple beginning, I will say there is the application network in which applications talk to each other. I have a specific backup network. I have a specific administration or management network. These are various purposes so that I isolate connectivity. An application network could be the network in which end users access the application. So that's a network by itself. A computer would have a network interface card associated to that network. Plus, if I'm running a database there, I might want a dedicated bandwidth for backup. So I might have an additional network interface card on that computer, and I will associate that network interface card to a backup network so that it is isolated from the application traffic. More importantly, when administrators log in and do OS patching or do any kind of configuration, they might log in through another network, which means my computer should have a third network interface card. Now, depending on the number of networks to which you want to connect your computer, you can land up having multiple network interface cards, and you can also do bonding. When we do bonding, we do something as follows. We identify the two network interface cards, for the example in this case, and we place them in the same network, but we are not going to use them individually, but we bond them together. This gives us two benefits. Number one, we get the benefit of scalability because my network interface card will have a specific bandwidth capability. So I can now get more network bandwidth in that network. And number two, I also provide for fault tolerance, or in other words, also called as high availability, so that even if one of these network interface cards is going to fail, my network connectivity for my computer is still intact because the other network interface card is giving me connectivity. So at an OS level, I can land up doing what is called as network bonding. And using this facility of bonding, I get the benefits of scalability and fault tolerance. So at the end of the day, you need to realize computers have network interface cards. Network interface cards are the ones that connect you to a network for a given computer, and the various options you can do with that is discussed in this video.